Everyone, today in this video we will see how to do a heap sort. So heap sort we will do using heap. So before proceeding to heap sort, I will recommend you to watch this video 4.3 where I talked about how to create a heap using a array, and another video 4.5 where I talked about how to delete a node from a max heap or main heap. So basically this heap sort is combination of these two: how to create a heap from a array and then how to delete the node and adjust. So heap sort is basically combination of both of these. How it is working we will see next. Now this is my input array and I have to sort this array, and the result will be something like this. So this is a sorted array and this is my input. Now to sort it using heap sort, I have to first create a heap out of this input array. So now the question is, what kind of heap I will create, a max heap or a min heap out of this array. So if I have to sort it in ascending order, then we have to create a max heap out of it. And if we have to sort it in descending order, then we have to create a min heap out of it. Why it is, we will see next. So for our example, we will talk about ascending sort only. So this is my input array and I have to first convert this input array to a max heap because we are going to sort it in ascending order. So the input array I converted to a max heap. All the max heap property are maintained. You can check, like the root node is greater than all other children. Like that way for 18 also, if you see, it is greater than all its children. So the first step is we have to create a max heap out of this input. Now onwards, whatever operation we will do in this array only. Okay. Now you can see this is the representation of the max heap and this is the array. Now first step for the heap sort, what we will do after building the max heap is we have to delete the root node and adjust. So for deleting this root node, this 101, we'll have to remove the node. Then in the delete node video, what we have seen is we have to place this last node in the root. Now as 8 is present here, what we can see is this is not a max heap. So we have to shift 8 down and place it to its proper position. So between 18 and 37, 37 is bigger than 18. So we have to replace 37 with 8. And again here we can see is between 27 and 1, 27 is greater than 1 and obviously it is greater than 8 also. So we have to do a swap between these two. Now the shifted value 8 is placed in a proper position. And now it's a max heap again. So what we can see is, what is the root now? The root is 37. And what is 37? 37 is the highest value in this max heap. So previously the highest value was 101. Now after deleting and again making it a heap max heap, 37, the root node, become a max value again. So now we can see the array representation. Here you can see 37, 18, 27, 16, 3, 8, 1, 2. Like that way it is presented. And as one node is deleted, that is 101, now the heap size reduced to 1. Previously it was from 0 to 8, now it is from 0 to 7. One empty space we can see here because 101 is removed. Now the effective heap length is from 0 to 7 and we got one blank space. Now for heap sort purpose, don't remove this 101 completely. Instead of that, place this 101 in this blank space and we will repeat this. Then what will happen? 101 was the highest value on the initial max heap. We replace that and place it on the last. Now in the next step, 37 will be removed. Then the effective length will become from 0 to 6 and we will get a blank space here also. And we will place 37 here. Then the root node will become 27 because 27 is the max value, next max value after 37. So that will also be deleted and placed in this position. Then 18 will come and occupy this place, then 16. Then what will happen? In the 0th position, 1 will come at last. Then it will become 1, 2, 3, 8, 16, 27. I missed 18 actually here. So like that way, it will be sorted. So that is the way we have to do heap sort. So other steps also I will show next. In this area actually I am getting less place to show it. So in the next area I will show what are the next steps. As 101 was deleted, then the max heap is like this and this is the array representation. Now we will delete 37 and place 2 here, then 2 will be swapped with 27, then 2 will be swapped with 8 and it will again become a max heap and that time the root node will be 27. So now you can see here another node actually reduced. Now the heap size is from 0 to 6 and now 27 is the root node and the 37 we deleted that is now placed in this position next to 101 left side. So next step we will delete 27. Now 27 is removed from the root node and it is placed here and this is the max heap structure again. Now next step wise we will delete 18 from the root node and then we will heapify again. Then 16 will be the next highest root node. Then 18 whatever we deleted we placed it here and this is the max heap. Now we will delete 16. So after deleting 16 it will become 8321 and the deleted 16 will be placed here. Next we will delete 8 and 8 will be placed here and 312 will be our max heap. Then we will delete 8 and then it will become we will delete 3, then it will become 2 and 1 and then it will be 1 and after that it will become the complete sorted array. Okay, and nothing to delete more and we have to stop our process. So step by step if you see, this is the way we have to do a heap sort. So what conclusion we can draw from here? Each and every time I am picking from the max heap what is the highest value, that is the root node, and I am placing it behind. Like that way when we are going forward, the last part, this yellow part if you see here, is the sorted one and whatever is highest here I am taking it out from here and I am placing in front of this and then it is become a sorted array. And then 3 also I am removing and placing here, then 2, then 1. So this is the way we have to first build a heap, then delete the root node and place it in the behind. That way we can do a heap sort. Now we will see what is the time complexity required to heap sort one particular array. Now we have to discuss what is the time complexity required for heap sort. So the first step for heap sort is we have to build a min heap or max heap according to our need, like which kind of sort we want to do, ascending or descending. We have to build a max heap or min heap from the input array and that will take on of time. Why it is taking on of time, that I will explain in a later video. Second step is we have to delete the root node and heapify. Means after deleting the root node, we have to again create it as a max heap. That will take O log n of time that I have explained in this video 4.5, deleting from max heap. And we have to repeat this step n time for each and every node until the max heap will be vanished. So the total time required for deleting and heapify is n into O log n. Now the total time required for heap sort is On plus n O log n, and that will be simplified to On log n. So the time complexity or the time required for running a heap sort is On log n time. So before moving to the programming part, we have to know two terms about heap sort. One is heap sort is a comparison based sorting algorithm that uses a binary heap data structure. So why it is comparison based? Because we are every time comparing and getting the max value and we are placing it behind. And another thing is heap sort is an in-place sorting algo. So no extra space is needed during the sort. What is in-place sorting algo? In-place sorting algo means we are not taking any extra space to sort it. So if you remember, we got the input array, we make or convert it as a max heap. Then in the same array only, where actually we created the max heap, there only we change the position and make it a sorted array. So no extra space we took. That's why it's an in-place sorting algorithm technique. Now we will go to the programming part. So coming to this programming part, in the delete from max heap program, which I explained in the previous video. There I have already taken a max heap and then I was trying to delete the root node. So this is the program which I already explained in the previous video. So if I run this program, you can see 101 I deleted and then it became a max heap again, and this is the max heap structure. So now as we learned that we have to repeat this procedure n time. So what we can do is we can put this delete part, delete and printing part, we can cover with a while loop. Okay, and then we can see what is happening. So if we run it again, then we can see first we deleted 101, then we deleted 37, then 27, and like that way we are going to the end and no more element is left in the max heap. Now side by side I will print the array structure also. So this is the tree structure, right? So below to that I will print the array structure also, how it is changing. So I will enable this method. This is just a print heap array method which is similar to print heap. It was printing the tree structure and this print heap array will print the array structure. So if I run it here, you can see 37, 18, 27, this is the tree structure and this is the array structure where 101 is placed in the last position. Then 37 I deleted, that also placed here, then 27 placed here, then 18 placed here. So each and every repetition, the highest node or the root node is coming here. Now you can see carefully, like after each and every iteration, when no more element left in the max heap, then I can get the sorted array. So this is the programming of heap sort, which is just a enhancement of the delete from max heap program. I will put it in the description box also. Thanks for watching this.